Okay, this is section 4.6. It's called a trapezoidal approximation. So previously, if I had given you a table, I would ask you for a left-hand rectangle approximation, or sometimes a right hand, or a midpoint. What we're going to do now is do an approximation using trapezoids, which is actually a better approximation than using just a left or a right hand. So I've got a bunch of values in a table right here, and I actually just made a rough sketch of some of the points right here. So the idea is I'm going to create a trapezoid between here and here, and I'm going to come up with a rough estimate for the area underneath this curve by creating trapezoids. So this would be my first trapezoid. This would be my second trapezoid, etc., and we'll just add them all up. The only formula that we need is just the area of a regular trapezoid, which is 1/2 times the height times the sum of the two bases. Okay, so I'm going to just go through and find the area of each trapezoid. So this is my first trapezoid here, which is from here to here. So it's 1/2. The height of the trapezoid is the difference in the x values, which is 0.75. And notice these are your two bases of the trapezoid, which are really your y values. So 15.2 plus 17.1. There's my first trapezoid. Plus my second trapezoid, I'm going to go from here to here. 1/2. Notice the width is still going to be, or the height is also still 0.75. Your bases are these. Notice you're going to use the 17.1 again, and then your next base is 18.6. And I'm going to continue on. So the next one also is 0.75. I'm going to use 18.6 plus 19.2. And then I've got one more trapezoid here, 1/2. Width is again 0.75. And 19.2 plus 20.4. And use your calculator, punch out these numbers. If you add them all together, your total sum is this. So this is a trapezoidal approximation for this area underneath that particular function. Now, you can do it this way if you want, but notice all of the pieces have the 1/2 because that's part of your formula. In this particular case, the height is always 0.75. So if you have a trapezoidal approximation where the data points, the width is the same, you can also do this. The 1/2 will be everywhere, so you can pull that out. The height is 0.75 always. You can also go ahead and pull that out of all the sums. Notice the first base gets used once, but notice all the bases in the middle gets used twice. This one will get used twice, twice, and then the last one once. So if you know that pattern, you can go ahead and say, okay, the first base gets added once, all the bases in the middle will get added twice, and then the last base gets added once. So this is another way to think about doing it. One other thing that you'll notice is if you actually did a left hand and a right hand approximation, what you'll notice is that the trapezoidal approximation is actually the average of the right and the left, the average of those two sums together. So the trapezoidal approximation is the best out of versus the left or the right hand.